identify materials that are solid. You'll notice they are solid because they will be in a defined structure, usually tightly packed and in order. Water does a great job of this when it's formed into ice. Particles stop vibrating, or I should say keep vibrating but stop moving around so much, and they become extremely tightly packed. Liquids, however, we could have the same amount of water as we do in the ice, and our liquids are in a random order, and more importantly, they're constantly in motion. This is why if you ever drop food coloring into water, give it enough time, provided the water isn't close to absolute zero, the fluid does mix around because the particles are mixing around still. Okay? At which point, last but not least here is gas, and so these particles are zipping around, moving really fast, and there's a lot of space between them, and they are not close together, although you can make them close together, but they don't like to be that way. And so gas particles are quite vicious in terms of their movement. So, quickly, low kinetic energy, high kinetic energy. This is somewhere in between. So, if I want to go and increase my kinetic energy, I would go from solid to liquid to gas. If I want to decrease kinetic energy, I would be going from, you got it, gas to liquid to solid. And, great question I probably would ask, if I wanted to melt wax, if I've got a candle, I want to melt the wax, what do I need to add to that wax to go and turn it from a solid to a liquid? You got it. Kinetic energy. Awesome. Alrighty. Let's see what we have here. Number 7, topic number 7. Insulators and conductors. Well, basically you just need to be able to identify the various two types. Now, an insulator obviously is good at stopping KE transfer. That means if I can stop the kinetic energy moving through something, that's an insulator. Great examples, you've got it, you heard it earlier in class: foam, wood, glass, and the big one, rubber. Conductors easily passes KE, and this is indeed most metals, the best being gold, and one of the more weaker versions, or one that doesn't move as well, is nickel. But most of the time people use copper, especially in like electrical wires. Alright, so those are conductors. Alternative energies. Any type of energy, anything other than fossil fuel use and nuclear. So this is going to be all your solar panels, wind turbines, biomass, biofuel. Let's see, go tidal, and I'm sure there's a few more that I could quickly look here on the board. Wind turbines, biomass, biofuel, tidal. Well, we'll leave it at that. Those are definitely more on the alternative side. So, that's number 8. Leaving us with the last topic, number 9. Please just remember, when it comes to current situations, most of our electric devices right here can be tracing back our electricity to the burning of fuels. In this case here, most of them are fossil fuels, and if that is true, most of these fossil fuels can be traced back all the way to the sun. Alright, we could replace the fossil fuels with wind turbines and so on and forth, and then we could just go and skip a lot of all these other terrible, wasteful, transportative type approaches to moving energy. So that's number 9. Alright, so this one right here, electricity. Great way to look at it. Currents. What, how, and who? AC current, what is it? Well, AC current will be alternating, positive and negative. DC is a continuous flow of electrons. In this case here, alternating current, the current goes back and forth, so changing from positive to negative. It can go great distances. And let's see, what else can we talk about? AC current. AC current is found being produced by generators, like your gas generators. And the big thing about it is that the electrons do not need to travel all the way to the work and back. Unlike DC, continuous flow of electrons to work and back. AC just needed to pulse back and forth, positive, negative, positive, negative. Let's look over here. Who is in charge of, or who is greatly responsible for alternating current? This is indeed Mr. Nikola Tesla. And DC would have been Mr. Mean Man Edison, who will someday be forgotten and Tesla will come into play. No, I mean, Edison's a great guy, but obviously most of you know a little bit more about these two, and they definitely were not friends for a couple of reasons. Alright, circuitry. We have series and parallel. Series circuits. If I had a battery right here, and I was to go and put a light bulb in here, and I put 3 light bulbs together in one giant continuous loop, this is indeed series. Parallel. Again, I'm using 3 light bulbs. In this case here, the benefit to one over the other, we like to remind ourselves that we still see these in Christmas lights, and we still see this in our house wiring. The benefits to parallel: if I take out a bulb, the remaining light bulbs will still continue to work. If I take out a bulb here, if the bulb goes out, they all go out. Most of you had this experience with Christmas lights. Alright, good luck on the quiz, folks. That'll be pretty much all that you're asked, alright? Have a good one. Study, watch the video if you need to again. Take care.